Hello everyone and welcome to this week's lecture on ISM 415 special topics. Last week we looked at machine learning, right? We looked at the different type of machine learning. We looked at supervised machine learning, reinforcement learning, and unsupervised machine learning. And towards the end of last week's lecture, we looked at one type of supervised machine learning, which is the regression problem. Now this week we are going to take the second part of supervised machine learning, which is now the classification problem. Okay, I'm going to take you step by step on how to solve classification problems based on the data science workflow. Okay, at the end of this lecture you should be able to solve your own problem and compete in in-class hackathon. So let's get started. Last week I briefly introduced classification for you, right? So what exactly is classification? Now classification is a type of supervised learning which specifies the class to which element belong to and also tries to predict the output variable, right? So for instance, if you have a data set, okay, and you want to predict whether, okay, let's say a data set of wine, like I gave you an instance last week. If you want to predict whether a wine is going to be good, normal or bad, it is dependent on other variables like the fixed acidity rate, the volatile acidity, the pH value, and others, right? And now the output variable that you are trying to predict, which is whether a wine is going to be good, bad, or normal, those labels are discrete in the sense that they are not numeric. Okay, so to make it simple, just like you're trying to classify a dog from a cat, okay, dog and cat from a data set, I mean, right? Or you want to classify good wine, bad wine, normal wine. You want to classify a male from a female and others. Okay, so that is classification. Now classification will have a huge range of applications like the spam email detection, which we are going to look at in NLP class. Okay, we can apply classification in identify customer segments. Okay, which category of customers belong to so and so. We classify we can use classification to determine loan approval. Okay, which customer is eligible for a particular loan. Okay, we also use classification to solve employee or customer churn. This is the one we are going to be looking at today. Employees promotion, then you look at customer churn in your hackathon. Okay, we can also use classification to identify if a kid will pass or fail an examination, and in fact the list is endless. Okay, so in classification we have different types. We have the linear model and the non-linear model. Okay, the linear model or linear classification consists of different algorithms like the logistic regression and the support vector machine, which we are going to be looking at as we progress in today's lecture. Then we also have the non-linear model like the k-nearest neighbor, the random forest, the decision trees, and other boosting trees algorithm. Okay, we are going to see them as we also progress. So let's start our agenda for today. Today we are going to be working on a real case scenario, okay, which the case study, which is the Yakub Trading Group. Okay, we want to predict an employee who is likely to be promoted in a company, right? Now this company was owned by Alhaji Yakub, okay, the father of Abdullah Baba Yakub, who is now 38, right? After many years of studying and working in Europe, he decided to come back to Nigeria to inherit the family business. Okay, and upon his resumption of duties in the company, okay, the staff of the company summoned him and laid a very important complaint to him that some of them have been unfairly treated, in the sense that some of them have not been promoted while they are supposed to be promoted. So him, Mr. Abdullah, being a just man, assured them that he's going to use the scientific means possible to make sure that any staff that is due for promotion will be duly promoted. So he now decided to hire us, we data scientists, to build a machine learning model capable of predicting an employee in the company that is likely to be promoted. Okay, which is a very, very important task. So he gave us a data, previous historical data of the company, which consists of different variables like the employee's number. Okay, this is a system generated unique staff ID. You know, employees in a company, all of them have their own unique ID, right? So you can identify them, just like your matriculation number is unique to you, right? So then we also have a variable called division. This refers to the department of each of the employee. Some of them might be in human resource, some of them might be in accounts, etc. Okay, we also have the qualifications, which is the highest qualification received by the staff. Some of them have their PhD, some of them have their MSc, BSc, and O level, right? We also have channel of recruitment, whether the staff were recruited via internal process or through referral or by an agent, right? We also have a variable called training attended, whether the employee attended any paid or unpaid training, okay, during the previous business cycle. We also have the year of birth of the employee. We have the last performance score, usually called the key performance index also. We have the year of recruitment. Okay, we have the target met, whether the employee met a target for the year. If yes, the score is 1, and if no, the score is 0. We have previous awards. We have training score average. Okay, they attended a training, what was their average score, right? We also had the state of origin, foreign school, whether the employee studied abroad or locally. We have marital status, whether the person is married or single. If yes, the answer is yes or no. We have past disciplinary action, whether the person have erred in some occasions and was disciplined or called to panel. Okay, we also have previous intra-department movement. Has the person decided to migrate from account to, say, human resource, for instance? If yes, put yes. If no, no. Okay, we have number of previous employers. What is the working experience of the person? Has the person been working for 12 years in 4 different companies or not? Okay, so that is all we'll be looking at in this week. We are going to be making use of these different variables to try to predict whether the employee is going to be promoted or not. Okay, so like I said, we are going to be following the data science workflow. Of course, you can see step 1 is simply starting with a question, and step 2 is to get our data, right? Okay, so step 3 is to perform exploratory data analysis. But for we to do that, we need to import our data into our working directory and into our Jupyter notebook to start working with it. So let's get started. So let's see. You already know the process. I've done all that. I've launched my Jupyter notebook, navigated to my working directory, so you can do the same. You also make sure that your data is saved in your working directory. Okay, so for me, my data is data set. So let's see. So the first step, as usual, is to import our libraries. Okay, so I'm going to write a comment: import important libraries. Okay, you guys are familiar with some of these libraries, so I'm not going to dwell deeply on them. So the first library we're going to import is the NumPy library, and you know the NumPy is simply used to convert our variables into arrays, because machine learning doesn't make use of data frames, right? So we import the NumPy library using the import keyword. So say import NumPy, then we can abbreviate it as NP. This is optional, you can decide not to do that. Then the second library we're going to import is the pandas library, which is a very important and powerful library for data manipulation, data cleaning, and exploratory data analysis. So we simply say import pandas as PD. The next library, of course, you can guess, is the matplotlib library, which enables us to execute powerful plots on our notebook. Okay, so simply say import matplotlib, then using the pyplot function of it, pyplot, then we can abbreviate it as PLT, Okay, now the next library we are going to import, this is the first time you're probably seeing this, is the Seaborn library. Now the Seaborn library is used for making advanced plots. Okay, it is built like over the matplotlib library. You are going to see some elegant plots that we're going to be making using the Seaborn library. So we simply say import Seaborn as SNS. Okay, then one more keyword you might want to import is the matplotlib inline. It is optional. Okay, what it does is it enables you to view your plot in a single cell instead of outside your cell, right? So we can say percentage matplotlib inline. Okay, now like I told you, this is optional, it's not compulsory. So once you're done with the importation, you can execute the cell by using Control Enter if you are using Windows, or by using Shift Enter if you're using Windows, or Shift Return if you're on Mac. So I'm going to pause this video to enable the function, the libraries import, then we can proceed from here. Okay, we've imported our libraries. The next step we're going to take is to import our data, right? So I'm going to write a comment, importing our data. Okay, as usual, our data is still in CSV format, which is short for comma separated values, but this might not always be the case. You can have your data in Excel form, which is familiar to you, right? You can have your data in JSON file, which is kind of a dictionary format. You can always read those things using your pandas library. So for instance, if we want to import CSV files, we use pd.read_CSV, right? Now if you want to import Excel, you simply use pd.read_Excel. Okay, if you want to import JSON file, pd.read_JSON. If you want to import which other file, tab file, that's a TSV, which is tab separated values. You simply use the same pd.read_CSV, but in that case you are going to set your delimiter to be tab. So let's import our data. I'm going to declare a variable called data for easy access. So you can call yours anything. Remember, this is a variable. So I bring my pandas library PD. Then I call the read_CSV function, read_CSV. So remember, I told you my data is in my working directory and the name is dataset. Okay, so I'm going to enclose it in single or double quote, doesn't matter. So dataset.csv, right? So I will execute this. Alright, so let's wait for this to import. It has imported. So remember, we are still in our step 2, which is getting our data set and cleaning them. Okay, so what we'll do next is we try to see the first few rows in our data, and of course you know how to do that. Simply call your variable name, then you use .head, right? This will give you the first 6 rows in your data. Okay, so let's see. Now this is our data. We have different columns here. Of course you can see you need to scroll to the right, okay, to see the rest, right? But if we don't want that, we can try to view our columns to see, okay, these are the contents in them. Simply call our variable name, then columns functions. We run this. You can see we have the different variables that we saw in our slides, right? And the final variable, which is the class variable we are trying to predict, is whether at the end of the year the employee is going to be promoted or not. So this is our target variable, and this one is based on the other independent variables. Okay, so let's enter the step 3 of our data science workflow, which is exploratory data analysis. Now the reason I'm leaving data cleaning for exploratory data analysis is because exploratory data analysis, as we saw in our last 2 weeks lecture, is all about cleaning your data and gaining insight from the data. So our data cleaning will be based on this step. So I'm going to say step 3, performing. I'm going to abbreviate it. Of course, you know EDA stands for exploratory data analysis, so I convert this to Markdown. Markdown. Then I will execute. Okay, now in the EDA, which is the exploratory data analysis, we are going to be performing several tasks. Okay, remember we are working on a real life problem here, so care has to be taken on steps we take to make sure we arrive at a reasonable and usable solution. Okay, so the first step we are going to take under EDA is to check for missing values. Okay, so checking for missing values. Please take note of the step I'm taking here, because in your hackathon, remember we are doing a hackathon. The competition is already hosted on Kaggle. I'm going to make a video showing you how to start the competition, right? You build a solution like what I'm going to be building now. I'm going to show you the steps. Then you upload your results on Kaggle. Kaggle will grade you. Okay, will tell you you have so and so accuracy in your model, but your test is also going to be based on that project. But now the grade for your test is majorly going to be based on the solution. That's everything you do on your Jupyter notebook. So you have to try as much as possible to explain each step. Okay, checking for missing value, you check it, then you write a brief markdown explaining what you saw. Okay, so I'm going to check my missing values now. The functions are already familiar with you. You simply call your variable name data, then you ask a question whether this is null. Okay, but it's not, we only iterate through your data row by row to tell you, okay, there is a missing value in this row. No, there is no missing value here, but that's not usually useful for us. We want to count the number of missing values in each column. Okay, so we simply use the dot sum function to get the sum of the missing values in each column. So this is it. Luckily for us, we only have one column containing missing value, which is the qualification column. Maybe some employees were reluctant in putting their qualification. So what we can do to save us more stress and to save us the problem of having to lose on important data, we are going to drop the qualification column entirely. Okay, so that we can retain the other data instead of trying to drop the NAs, which will also affect the other columns, okay, which we don't really want. So I'm going to write a comment which is remove the column with missing values. Now, assuming we have multiple columns containing missing values, it might be ideal for us to drop the NA, but since we only have qualification column, which might not be relevant to us anyway, okay, based on the level of machine learning we're doing now, we're still at the basics. When you advance in machine learning, you can build a neural network to replace these missing values, that's to predict the missing values individually, or you can fill the missing values with something else like -1 or 99, which are sometimes useful in competitions on Kaggle. Okay, for now we are going to drop the column entirely, and to do that we are going to use the drop function. So I'll simply call my variable name, which is data. I'll use the dot drop, super easy, right? Dot drop. This dot drop takes in different arguments, but before I start, I want to show you how to get help on dot drop so you can see some of the arguments it takes. Okay, these steps are familiar with you, please don't forget it. So you see dot drop takes in, the first one is the label, the next one is the axis. Now if the axis is 0, you are trying to drop the row. If the axis is 1, you are trying to drop the column. Then you have index and blah blah blah. So what we also have in place here, so we see use in place there. So we are going to be making use of 3 parameters: the labels, the index, and the in place. So let's continue. So I'm going to say dot drop. What column am I trying to drop? I'm trying to drop the qualification column. So I'll go ahead and copy this, Ctrl C, come here and paste it, Ctrl V. Okay, give me a moment. Okay, now the next step, the next parameter I'm going to use is the axis. Okay. right? So the axis I'm going to specify is, since we are dealing with the columns, I'm going to specify the axis to be 1. Then, since I want the change to be made in my original data set, I also specify in place to be equal to true. Super easy. So I will go ahead and execute this code. Cool. So I'm going to rerun this to make sure that the columns has been dropped. Of course, it has been dropped, so we don't have the qualification column here anymore. So the next thing we're going to do now is we look at our data again. So instead of scrolling up, I'm going to say data.head. So please take note of all these steps I'm taking. They are very key to understanding machine learning, especially classification. So you can see some of our columns are not numeric. Okay, you can see some of them, like the division, the gender, the channel of recruitment, and many others. They are letters. They are words, letters, but not numeric. So this is not really useful in the area of machine learning, because we have to convert this in a way that the machine can understand. The machine can not understand male or female. It only understands 0 or 1, right? So what we do is we enter a next step under our EDA, okay, which is data pre-processing. So in data pre-processing, we try to pre-process our data in a way that could be useful for machine learning. Okay, so go to write a comment, data pre-processing. Cool. So the first thing we're going to be doing under data pre-processing is to convert these characters into numbers. And to do that, we have a very powerful function in scikit-learn, which is the label encoder. We have various ways of converting characters into numbers. Like we have the one-hot encoding, which is which is going to be a bit complex if I use it for you. So we're going to be making use of the label encoder. We simply convert the first occurrence of the item in the row into 1. The next label will be 0, 1, 2, and so on. So let's get started. We are going to import label encoder from our scikit-learn preprocessing library. So we simply say from sklearn dot pre-processing. Okay, we want to import label encoder. Please take note of the capitalization. The L is capital letter and the E in encoder is also capital letter. Okay. Alright, so let's import this. Okay, so take a while. So it's taking so much time. Okay, we've imported our function, so we're going to assign it to a variable, call it LE for easy reference. Simply say LE is equal to the label encoder function. Okay, label encoder function. So I'm going to convert one of the column into numeric variable. Then I'll pause the video and do the rest. Okay, so we don't have to waste so much time. So I'm going to take the easy one. Okay, let's take the first one, which is division, and convert it to numbers. So first of all, I have to index division data, then I index division. Okay, so I'm going to set this equal to. Now in this label encoder, I'm going to make use of the fit transform. Okay, that's what converts our column into numbers. Okay, so I simply say le dot fit underscore transform, then open parenthesis. I simply copy what is on the right here inside the parenthesis. Ctrl V. So let's execute. Okay, cool. So this works. So let's rerun our head and take note of the division column. Awesome. You can see our division has been converted into numbers, which is super cool. So I'm going to pause the video now and repeat the same process for the different columns that are not numbers. Okay, so we don't have to waste so much time on this part. We have a long way to go. Okay, now I've repeated the same process for the different columns without numbers. Okay, so you can see all you just need to do is to copy everything and edit. Okay, just replace the new columns with the division. So when I executed this and looked at the head of my data, you can see all the columns that contains character are now containing numbers, which is now useful for us. But of course, in order for you to build a machine learning model that without bias, for instance, you have to eliminate some things, right? For instance, how can you say that you want to determine whether a person is going to be promoted or not based on the person's state of origin? Is it not bias, right? Or based on the person's marital status? Does it mean those people that are married are more likely to be promoted, or those people that are not married are more likely to be promoted? Or is it based on their what's it called, the year of birth or the year of recruitment? So some of all these variables, if you use them to build your model, they add what we call noise to your model. Okay, your model becomes biased. Okay, so that brings us to the next step under our exploratory data analysis, which is feature selection. Okay, so I'm going to write a comment: feature selection. Now there are hundreds of ways to select important features and build a fantastic model from this data, right? But based on we are just starting machine learning, I'm going to show you just the basics. Okay, so we are going to be making use of the correlation. Of course, some of you did math in your years in school, right? So you already know that correlation is simply trying to identify a relationship between one variable or another. And we have some matrix of measurement. We say if the correlation is say 0.8 and above, it means there exists a strong positive correlation between those two variables. In other words, as one is increasing, the other is also increasing, right? So then when the correlation is less than 0.8, that's minus 0.8, we say that there exists a strong negative correlation between the two variables. As one is increasing, the other tends to increase at a greater pace as well. Okay, now we want to see how this variable, because our target variable is whether the person is going to be promoted or not. So we want to see how this variable correlates to our target variable. And to do that in Python is super easy. we simply calculate the correlation using the CORR function, which is the core function if you want to pronounce it. So we simply say data dot core. So this gives us the correlation table for these data sets. So let's take a look. So you can see division and division, that's division against division is 1 because this is a perfect correlation. Is like saying what's the difference between you and yourself? Is 1 because you are yourself, right? So if you want to, the correlation between gender and division is negative. That means as the gender is increasing or reducing, sorry, gender is constant, so as the division, in fact there is no relationship between them, that's why you're having negative here. So you can also check the rest, but for us to go through this, it will take us some time to really figure out some of the things we need, and we don't have so much time to waste. So I'm going to show you a way you can plot your this your correlation table. Is called heat map, and heat map is a function in our Seaborn library. So I'm going to briefly show you. So what you simply do is you say SNS, which is our Seaborn dot heat map. So this heat map is going to take in some arguments. So the first one is going to take is your correlation. So I'm going to copy this and paste here, Ctrl V. Then I put a comma. Then one more variable. It has many variables, but I'm going to just focus on this 2. So the second variable annotation is equal to true because I want to see all these numbers displayed in the plot. So I'm going to go ahead and execute this. So give it time. Let's see. Okay, you can see that our plot is looking terrible because we have lots of data points, okay, on the heat map. Now there is something you can do. Of course, just know that this is optional. We're still not going to be using this per se here, okay. We're not going to be using this heat map, okay, but there are some things you can do. You can set your plotting parameter, okay. So I'm going to paste the code here. You don't have to worry about I'm not going to explain how I got the code. You can just use it as a script. You can use it to set your plotting parameter anytime without bothering too much. So like I said, this is optional, so you don't have to really do this. Okay, so now what we are going to really use is we are going to use this table, okay, but we are not going to be using the full table. We want to use the different variables and how they correlate with the target, with our target variable, okay. So sorry about that. So I'm going to do that now. So what I want to do is I want to plot my correlation table and index the target variable. So I'm going to say data dot co, which plots my correlation table, which is this, right? But I'm not just interested in the full table. I want to index my target variable. So I'm going to put, okay, you can see how that the plot has become very big, which you can use on your right hand side. You can see as the color increases, that changes. You can see it indicates whether the thing is becoming strong positive correlation or negative, strong negative. So you can use this if you want, okay. So for me, I don't like wasting so much time on something like this, so just find the easy way out. So I'm going to index the my target variable, which is promoted underscore or underscore not, right? So I'm going to execute this and see what we'll have. All right, so you can see how the different variables affect our promoted or not column, right? But this is not entirely useful per se, because we have negative here and there. So we want to sort the value. Okay, we'll have negative one side and positive one side. So I'm going to do that using the sort value function. Sort underscore values. Okay, so I'll do this. All right, so we can see that we have the negative on top and the positive on top, which is now very useful for us. So I'm going to write some. Okay, let me assign this to a variable correlation. So remember, I told you some of the major variables we are going to use are the ones that really affect our target variable in a positive way. So I'm going to filter them by simply saying print most positive correlation, positive correlation. Okay, so this I'm going to let it be how do I put it? I want to select the top 5 positive correlations, so I'm just going to say comma here, correlation. You can see that the positive ones are on the bottom. Okay, so I'll use the tail to call it correlation dot tail. So I don't want everything, I just want the top 5 positive correlation. I'm going to copy this as well and do that for negative. That may not be necessary. Okay, Control Z, Control C. Okay, most negative. Alright, okay, so I'll change this to head. Alright, so let's execute. So cool, you can see the top 5 positive correlations are here and the negative ones are here. So I'm just going to make use of the positive correlation. So that brings us to our next step, which is separating our data into dependent and independent variable. So this place is where some of you found it challenging during your assignment. So I saw some of you doing some things. Of course, I introduced a method of extracting your columns, okay, using the ilog function, but that seems to be complex for you guys. So I'm going to show you a much easier way of doing that. So I'm going to write a comment, which is separating our data. So let's always make sure that we are looking at time. Our data into dependent and independent. Okay, so to do that, of course, we are going to be making use of our X and Y as well. X stands for the independent variables and Y stands for our dependent variables. So in our for our dependent variable, we are not going to be making use of all the variables, just these 5. Okay, so I'm going to index them from here, from our data. So index The first one is the last performance score, so I'm going to copy this, Ctrl C and paste, Ctrl V, comma. The next one is the training average score, so I copy this as well and paste. The next one is the previous awards, so I'll copy this as well, Ctrl C, then I paste. So I hope this one is clearer and easier for you. Okay, all you just need to do is to index them, that's all, instead of doing the iLog. Then the last one is the target met, Ctrl C, Ctrl V. And of course, if you run this, we have a data frame. So let me show you an instance. Let's execute this and see. Okay, you can see we have a data frame, but this is not entirely useful because our machine doesn't take in data frame. So we have to convert this to arrays by just using the dot values as we used last week. Dot values. So cool, we have our data now in array. So the next thing we have to do is to select our dependent variable, which is super easy. Data promoted. Okay, promoted or not. So if you're wondering what I did to get the pop-up, I just pressed tab. Okay, so when you press tab, you get all those things. Okay, dot values again, values. So I'll execute. Alright, cool. Now we have to enter the next part, which is splitting our data. Okay, of course, we did this last week. We have to split our data into training and testing sets. We use the first part to train our machine and the later to test our machine. So I'm going to say x_train, comma, y_train, then comma, x_text, comma, and y_text. But of course, before you can do this, before you can use this, you have to have imported your train test split function. Okay, so from your scikit-learn, so we simply say from sklearn dot model underscore selection import train underscore test underscore split. So we'll do this. So now we set this equal to our train test split function. Ctrl C. Set this to our train test split function, which takes in some parameters like the independent variable, the dependent variable, the test size. We can set the test size to be 25%. Okay, so we use 75% to build our model and 25% to test it. So I simply use 0.25 for it. H train, Y train. Okay, everything is fine. So I will execute. Alright, this is done. Now we enter step 4 of our data science workflow, which is applying techniques. And in this case, we are applying machine learning. Okay, step 5. This is step 4. Building our model. Okay, so as indicated in your slide, you are going to see some detailed description of some of the models we are going to be using. We are going to be making use of 5 different models. Okay, we are going to be making use of the decision trees, the logistic regression, random forest, support vector machine, and gradient boosting classifier. Okay, so I won't go deep into explaining all this because that will result in doing some mathematics. Okay, so let's just focus on using the algorithms for now. Then in future, I'll be dropping a video on how to look at those algorithms in depth. Okay, to study them in details. So the first one we're going to be using is the decision tree. Okay, decision tree model. So I have to be looking at my time so I will know how to explain. This video doesn't have to take so much time. Let's say 1 hour 7 minutes tops. Okay. Oh, we are running out of time. Okay, now decision trees is just based on, as the name implies, decision. Like if you want to watch, for instance, Harry Potter, you have 2 decisions to make, whether to ask a friend or to go online. Now when you ask a friend suggests so and so for you. Now your decision at the end of everything is based on a tree. Okay, based on the information, the other information gathered from maybe from your friends or from the internet. So that's what majorly decision tree is all about. You can check out the slide for more explanation on that. So to use decision tree, we have to import them from our scikit-learn library. So simply say from sklearn dot tree. So we import decision tree. So you have to also take note of the capitalization tree classifier. Now the reason why you have classifier at the end of it is because we also have decision tree regressor for solving regression problems. So when you're done with this, you execute. Hopefully it posts successfully. Now we are going to assign this to a variable. We assign this function to a variable called classifier. Okay, so this classifier, just like we did in regression, this classifier is going to hold this function. Ctrl C, Ctrl V. Okay, then next, okay, so I don't have to be running all this in different cells. Next, we have to fit our model. I told you last week, you fit your model so that the machine will learn that, okay, so and so variable, when so and so parameters are in the independent variable, this is the result, the outcome in your dependent variable. So that's what we're going to be doing using fit. So I say classifier dot fit. Okay, dot fit. So what do we fit? We are trying to build our model, so we are going to be using the training set x underscore train and y underscore train. Then next is we make predictions. Okay, so after building your model, the next thing, predicting our target variable. So the next thing we do is to make predictions. Okay, so we can declare variable y underscore pred. Remember, this is a variable, it can change, you can decide to change it. So which is going to say classifier, we use the predict function, predict. Okay, now what are we trying to predict? We are going to predict x underscore test, right? Our testing set. Alright, so this is basically it for building our model. Let's execute. Hopefully everything works well. Okay, so okay, we are having an error on non-label type continuous. Oh, that means we made a mistake somewhere here. Okay, yeah, we didn't arrange this properly. The S train and X test comes first, then Y train and Y test comes later. So let's change it. So please take note of this. Okay, so I'm going to put a comma here. Okay, Y underscore train. So I'll execute this now. Then I'll have to just rerun this now. So let's pause. Hopefully it works. Okay, it works now. Okay, now the next thing we have to do is to calculate the accuracy of this model. Okay, so we'll see how accurate our model is. So for that, we have to import accuracy score from our matrix function in scikit-learn. So I simply say from sklearn dot matrix, okay, import accuracy score, accuracy underscore score. Okay, so let's do it. Okay, imported successfully. Now this accuracy score is just going to take two parameters, your testing set and your predicted value. Okay, so I simply call this function accuracy score, Ctrl C, Ctrl V, accuracy score, which is Y underscore test, comma, Y underscore pred. Of course, you know the difference between them. We use the training set to train our model to make a prediction, which is Y predicted, and we tested it using a historical data to see how dependable our model is. So let's run this now and see. Alright, so you can see our model is 92% accurate, which is encouraging, right? So you can make some few modifications to increase your accuracy. So let's quickly move on to our next algorithm, which is the logistic regression. Hope we'll have enough time to finish logistic regression. So this is a linear classification. Okay, that means it draws a straight line to capture some data points, just like the linear regression. So we are going to import this logistic regression from the linear model. So simply say from sklearn. You can see how powerful sklearn is. The linear underscore model, import logistic regression. So let's execute this. So he imported successfully. Now every other thing remains the same. Okay, so we can just quickly copy this. So that's machine learning for you, and make some few modifications. Control V. So we're just going to copy this again and replace it here. Control V. Alright, and we are good to go. So let's run this line of code. Okay, So don't worry about the warning. That's a future warning. Future is still to come. So then now, why this execute? Okay, as executed, let's check the accuracy of our model. Control C, paste it here, then run it. You can see we have our logistic regression gave us 91% accuracy, which is smaller than this. So that could tell you a lot of things, because it also tells you that our data is not really solved using a linear kind of approach. So the next algorithm we are going to be looking at is the random forest, which is also based on decision tree. Random forest model. Okay, so to do that, we are going to import the random forest from assemble in scikit-learn as well. So I simply say from sklearn dot ensemble import the random forest classifier. Now the reason why, of course, you have classifier at the end of it is because you also have a regressor for this classifier fire. Okay, so let's see. Import random forest classifier. Shouldn't take so much time. Okay, now so I've simply copied this part of the code and executed, changed the logistic regression to random forest classifier and calculated the accuracy. We have an accuracy of 92%, okay, which is slightly higher, okay, a bit lower than the decision tree algorithm. So this is where we are going to end for this class. You can find the solution for the other algorithms in your slides. Okay, everything is there. So one more thing, I want to tell you that you don't entirely have to depend on your correlation. You can play around with other variables. Okay, maybe trying to use other variables can give you more accuracy. For instance, if I decide to delete these two variables here, delete these two variables and add one more, let's say which one should I add? Let's say I decide to add the division, for instance. Division. Okay, so I decide to add the division of the individual. Let's see what accuracy we are going to get. So I will execute this. I'm going to rerun all the lines of code, so keeping note of time too. So just run everything, then run the model building. Okay, you can see that the accuracy increased from 92% to 94%, which is super cool. So you can try to experiment with other variables. Don't depend on just the correlation result you get. That's what I'm trying to emphasize here. Okay, so we're going to stop here for this video. So go through your slide and get more details on the other algorithms, and I'm going to make another video to prepare you for your hackathon, which is also going to count for your test as well. Okay, please go through them and do well to compete. Okay, and till we see again, enjoy data science and machine learning. Bye.